You are welcome back to my YouTube channel. I remain educator. Thank you, everyone. Now, today we're considering mensuration of solid shapes, that is 3D shapes. They are shapes that don't just have length or breadth, they equally have thickness. That is, they are objects that we can measure their depth. And an example of that quickly, let's consider like cylinder. The cylinder is a solid shape. Any shape that is cylindrical in shape, I consider it to be a cylinder. And what are the things, properties we consider about that? We consider the cross surface area of that cylinder. We consider the volume. Then from there, we can also consider the capacity. We can relate that to the capacity. Then from here, we consider also the total surface area. That's tend to be TSA. Let's have an example. Let's say we have this. Let me have a bigger shape. We have this circular base. So let's say we have this is a cylinder, and this top is circular. The base too is circular. So what happens? It's going to be having a diameter. This is a diameter. This place too a diameter. But let me stop here to form the radius. So we have this. This is the radius, and this is what? This is the perpendicular height. How do we measure some of these properties in this shape? What do we do? Let's go. Now, to calculate the cross surface area, because it is cylindrical, what will be the cross surface area? The cross surface area is 2 pi RH. That is 2 times the pi. There your pi, of course, can be 22/7. This is a constant. 22/7 upon 7 or 22.142, depending on whichever form of number you want to use. Then, what happens to the volume? Don't forget, volume of a solid shape is what? Is always given as what? The base area times the perpendicular height. So what is the perpendicular height here? So what is the base area? The base is circular, right? So that will become what? Pi r squared times h. And that is pi r squared h. Good? Exactly. So what happens again? If I calculate the TSA, we need to consider when the shape is having this very particular cylinder, if it is closed-ended or open-ended. Now, what happens if we have a cylinder that is having only, so that this cylinder is just one, the top is closed. So if it is closed, what will be the TSA? Let's go. Don't forget this remains the radius, but this place is open. So what we have? Consider the area of this pi r squared and consider the cross surface area, and that is 2 pi RH. These two will give you the TSA, the total surface area. This is what? One end closed. What happens when the two ends are closed? Just make sure you have this. The radius is still there, it's still valid. So what we have another pi r squared. This. So everything, the total CSA, you now have what? You now with this pi r squared plus pi r squared plus 2 pi r h. So that will be 2 pi r squared plus 2 pi r h. And now you can still factor out 2 pi r open bracket r plus h. This will be the TSA for 2 enclosed cylinder. We are going to be treating an example in the next video. Thank you very, very much for joining me.